We're going to introduce Matt right now, and I'm going to start with his fun fact. And when Matt told me this, my jaw was on the floor. I couldn't believe it. So Matt has, I think I'll get it right, but Matt has performed in front of a crowd of 120,000 people. He's singing and guitar.
Yes.
In front of 120,000 people, which really, it's like, we're not worthy. Like, that's amazing. And
it was awesome. It was just a sea of heads. I mean, they had bodies as well, obviously. It would be horrific. They were alive. Everyone was alive, as far as I could tell.
And with that, Matt.
Thank you. Well, it's an honor to be here, it really is. And what great quality of talks we've had so far. I mean, I really am blown away. By the way, I wear red socks. I don't know why everyone hates them. I don't get it. So, a bit about me. I've been doing Go for a long time. I blog on mattryer.com about Go, and I use it full time at Grey Meta. So it's cool. I do Go all the time. That's my life. I also wrote Go Programming Blueprints, second edition. It's available now. What? Does it have all new chapters? Yeah, it does have all new chapters. That's a good point. Protocol buffers, gRPC? Yes, you've got it. That's correct. Thanks. Is that what? Am I making these up? Well, don't ask that one. And I'm not Banksy. Okay? I don't know where these rumors come from, but yeah. Although someone did point out that is exactly what Banksy would say. I'll leave it to you to decide. You make your own minds up. Quick little interesting fact. Apart from there not being a timer there. This is Wayne Manor, which is actually Wollerton Hall in Nottingham, which is where I'm from. So that's where they filmed in the Christian Bale movies. That's where they filmed. So that's my link. Thank you. Yeah, that's not quite what everyone else had, but I'll take it. So first of all, I'm talking today about quality tests and testing. So quick show of hands. Who writes tests with their Go code? Awesome. Keep your hands up or put them back up if you've not followed instructions. If you write the tests first. Okay, so interesting.
All the time or just like some of the time?
Yeah, it's not really meant to be interactive, guys. If you don't write tests, then you're either very brave or something else. So what is a test? Let's start from the very basics. Okay, so we have this batify function. And this is going to take an item and tell you what Batman's version of that item is, right? And then we have a test for that. So it's a piece of code. It's code that runs, that calls your function, and makes sure that the function does as you expect it to. That's basically what you're doing. So the nice thing is that this is real code, okay? Oh, where? Does it matter? Okay, yeah, Barcar, yeah. Right. Thank you. Yeah, make sure it fails first. We'll come to that. Thanks for that. Someone write down her name. Okay. No. So why do we write tests then? We can get computers to check our work for us. That's kind of the key point, really. And it does it automatically. We all will test code even before we had unit testing. We would all test our code, right? We'd write it and then run it and see if it worked. And if it didn't, we'd tweak it and that. So this is like having like a robotic butler that does that for you. Sorry, I realize how English. Any kind of computer thing that doesn't get tired, it can do it. And in Go, because of the builds pretty quick, and because the code runs nice and fast, you can actually end up getting to the point where every time you save your file, you're formatting it, you're sorting out your imports, and you're building and running your tests for that package. You can do that, and that's what I do. And so that's why I kind of really am into test-driven development, which I'll talk a bit more about later. You end up with a suite of tests, in theory, that verify that your package, your code, does what it's meant to do. And that allows for bold and robust refactoring. So this is one thing I really like, is I can, in my projects, if I'm happy with the test coverage, I can be quite brave about breaking things, pulling them apart, changing things. And as long as my tests still pass, then I know that I haven't broken anything and things still work as expected. Another nice thing is if you do testing properly, then you get to the point where you know when something's broken, but you also know what's broken. And there's a kind of art to getting testing right where it points, almost like laser focus, to the problem, the thing, whatever it is that's changed or broken. And sometimes you think, okay, well, I have to update the test because actually it was the test that was wrong, which is why I did that deliberate mistake earlier. Or you find a bug that's in the code and you get to then fix it. If you want to know how, you can demonstrate the intent of code as well with tests. So you can actually look at test code and get a clue, in fact, see real examples of what certain functions do. And code becomes the documentation as well. So, and it's cool, if you look in the standard library, we've seen today earlier from some of the other talks, if you dig into the code, you can go and have a look at what it's actually doing. We can also look at the test code alongside it and see what's passed in, what gets returned, the expectations of that, and you see real examples. Brad's tests for the HTTP package are particularly entertaining if you have some time. So test-driven development then. So this is kind of like you can do unit testing after, and you end up. It honestly feels to me now like a bit of a pain to have to then go back. It feels like a chore that I have to now go and add tests, which is why I write my tests first. And test-driven development is that. Essentially, it's a process where you write the test code first. And you could imagine in the real world, if you think about it, it's kind of a bit crazy, because how can you test something that doesn't exist? And this is why I think people initially, they struggled with this idea. If you're going to have a bicycle, and you say to like Johnny, can you test the bicycle? And there isn't a bicycle there, it's probably not going to have much success. But that's okay, in software it's just a failed test. So then we'll add a wheel. Johnny, come back, have a go on that. Right? Quickly, Johnny's going to get annoyed because, well, it's futile. But in software, that's not the case. We can write these tests, and they will happily try and do the things. And you actually end up with a bit of a to-do list. So you have, sometimes mostly it's errors, right? You're testing something that doesn't exist. So maybe you're calling a function that doesn't exist. Well, that's an error. So that gives you then, the next thing I need to do is make this test, well, add the function to move on from that point. If you run it again, you'll see, it's meant to return something and this one doesn't. So you can kind of use it like that. I mean, that's an extreme example probably, but you kind of get the idea. And so this is the process then. So you write a small piece of test code. You don't write all of the whole thing up front. You just write a test, ideally. And then you run to see it fail. And that's a very key point, which somebody very rudely shouted out earlier. But it's a good point, but still a bit rude. So you run the test and see it fail. And that's vital, because can you imagine a test that can't fail? You're not saying anything about your system. It's like saying assert true is true. It's kind of pointless, and you're not really adding any value. So what we want to do is we want to see that fail first. That also means when it passes, we know that the change we just made that pass. Okay, so that's kind of key. And there's actually different kind of philosophies around all this stuff, and you can get very dogmatic about it, or you can treat it kind of like as a bit of an art form, which I think it more is than a science. Ideally, you do the minimum amount of work you can to make it pass, because the idea is you want great code coverage. Luckily, the Go tools make it very easy for us to find out how we're doing on that front. So test-driven development, it's evidence-based programming. You're proving stuff. It's not saying, oh, yeah, I wrote this code, it works. You actually can say, yeah, I wrote this code, look, and here are the tests, and they're passing. You don't need to rely on anything other than just that evidence. And you can prove bugs as well, or missing features. The best kind of pull request or bug report is when it contains a failing test. And suddenly, you're talking the same language now. You're talking in terms that everyone can agree on. And either, maybe you might say, okay, well, you've misunderstood the point of this function, maybe, or, yeah, actually, that should pass, and it doesn't. So cool, we're gonna move things forward. You get a kind of protection from regression because you've got this like a safety net. And sometimes harness is used and stuff, and it kind of makes sense. It holds your project, it holds your code in place, and you do get that protection. And essentially, what happens is if you mess around with stuff and it breaks something over here unexpectedly, you're alerted to that fact. And if only one test fails, then that's really laser sharp. That's pointing directly to the problem. Sometimes that's unavoidable, and you'll end up, maybe you do something that's quite low in your code and or in your project, and you break 3 or 4 or 5 tests. I mean, that's a clue also that it's something quite low level. And also, of course, you've got the context of as you're working on it anyway. You can write tests for each other too. This is cool. So if you're doing pair programming, one of you can write the test, and the other one makes it pass. So that's kind of nice. You also get things out of your brain, and you become the first user of your code because you actually, you're using it in your test code. So you get a feel for it, and you kind of, you know if there's any smell in there or something doesn't quite work. So one of the criticisms that I hear sometimes is that TDD, people rely on it to let the software design emerge from that process. And I think that you shouldn't do that. You should still think, still do design. Don't skip the design step. It's important to remember that TDD is an implementation time activity. It's something you're doing as you're actually implementing the thing. Not something that you do in place of any of the other parts of just sensible kind of building software that we expect. So let's talk about quality tests. What makes tests quality? Well, there are different types of tests. You have end-to-end tests that are testing everything, and they're quite sweeping. Then you have kind of integration tests, and they sort of test boundaries between components. And my favorite is unit tests. And I like them more because they're more granular, and they're more laser-focused. So I love unit tests. Imagine these two tests here. So I have here, can I create an account and send money to my friend? Versus, when I sign in, am I given an auth token? Now, if the auth token thing breaks, both of these tests are going to fail, but which one tells you what's failed, what's gone wrong? The first one's kind of like an end-to-end test. There's loads of things that have to happen in order for that to work. And it's not insane to have that test. You want to have that confidence. But this bottom one will say, oh, I'm supposed to get an auth token, and I didn't get one. Not in that attitude. It's just a failed test. But essentially, points you straight to it. So unit tests, smiley face. An end-to-end test, a bit of a sad face, only because if anything breaks, you get your end-to-end test fails. That's why I find unit tests to be way more useful. Cool. I also love table tests. So you've probably seen this, but I just want to be a little bit comprehensive in some of this, so that this talk can be useful also for people that haven't done much testing. Table tests essentially make a slice of anonymous struct, and it can be any type, so you can have any fields in there, and I just have in and out. And then you for over those, you loop over them, and use the subtest to run that particular case, and you actually can then make the assertions, which I do here. I'm calling batify, passing in the test in and making sure that I get out what I expect. This is nice because at a glance you can see the ins and outs of this, what we expect this code to do. It's very easy for anybody to add new cases. You just go and throw in another line, into that list. Another nice thing you can do here is, let's just explain what I said. You can do setup and teardown very easily using this pattern now. So outside of the for loop, you can do kind of general setup and then defer the teardown. And then inside the for loop, you can do per test setup and defer the teardown, since it's a function that you pass into that run method. So it's very nice and feels very familiar, and it's very Go. There's not much else. There's no magic going on there. Nothing to learn. Okay. Oh yeah. So if you want to do shared setup and teardown, this is a nice pattern. Essentially, what you do is return a function that is a kind of cleanup function, and what this lets you do is you write test code that calls a setup and just defers that returned function. So your code, as using this setup, doesn't have to know what's really being set up. It doesn't have to know if it has to worry about tidying up after itself. It just defers this cleanup function. It could do nothing, which actually does in the error case there. The return function it's just kind of no op. But if in this case the database is open, it closes it. So that's nice, a nice little pattern. You end up writing code like that, and you'll have that kind of similar pattern everywhere. Again, any new Go programmer that joins your team, that's really clear, I think, what's going on. And that's one of the goals of this. So I like to do, in test code, a different package name. So it's an error in Go if you've got a package that contains a folder that contains Go files that has mixed packages. You'll see an error. But that's not the case if it's test code. You're allowed to do that. So if you do, it means you're testing your package kind of from an external point of view, which is, don't forget, how your users are going to use this. So you can see here in batify.go, we have the function there, and it's in package batify. And then in batify test, the package is batify_test. So, and then you import batify, and you get to use your API as your users will. And you can see here, you notice things like this, batify.batify, which is, we didn't notice before, and maybe wouldn't notice if we're just calling batify. So you get to see it from that external point of view. Dave Cheney doesn't like this, and he says, if you don't trust yourself not to use private methods in unit tests, then I cannot help you. So thanks, Dave. So that's a good point, because testing externally like this, you can't fiddle around with internals. But that is kind of probably not the main point. For me, the main point is you get this early exposure to the footprint of your API. So your test code there helps you avoid things like this. I've got this tea package, and I can brew tea, and I have a tea brewer. But you can see I've kind of made some naming. It's a bit weird. I don't need to say tea.brew tea. It's enough to say tea.brew or tea.brewer. So we might then change the batify function to item. So then it's going to be batify.item, something like that, which you wouldn't necessarily have thought of before. Interface tests. This is quite cool. We released a package called Stow, which is it's an abstraction on top of cloud storage, like S3 and Amazon and that is the same. Amazon and Microsoft Azure and all these kind of Google cloud storage, these blob stores. So we built an abstraction of that, which is based, and the package is just interfaces, and then we have different implementations. Well, we just have a single method that we call that tests just from the interfaces. It's saying, I'm going to create 3 containers, put these items in them. I'm going to get the list of containers and make sure that's right. I'm going to go inside a container and get the list of items. I'm going to read back this item. All the things that this package lets you do. The test just operates on an interface. So that means implementations, they just have to satisfy this one test, and we know with confidence we can add that to the project. It's passed. If there's something missing, then it's missing in this interface test, and we add it, and then we get the benefit. We run the test suite. We get the benefit of then having that additional check across all implementations. Here's a simpler version. We have this store interface. You can get and put things. So then it can write a test where we pass in a testing T and the store implementation, whatever that is. And we're just talking in interfaces only, but we know what we expect and stuff. So if you can do that, it's great, because it makes it very easy to add implementations. Test code is code. The clue is in the name test code, so if you spotted that. But so treat it as a first-class concern. look after your test code. You know, it's part of your project. In some projects, it's more important than the implementation code. You can even get away with some kind of sloppy implementation code, which you can clean up afterwards, as long as your tests are solid. Don't let old tests build up, right? It's very, I think, you think, yeah, the more tests, the better, right? It's tested more, but it's not really that, because, you know, you want this laser-focused thing, which you could lose, and you also want the code to be readable, and you want to be able to just show somebody that and explains what your actual package does or whatever. And Eleanor McHugh said, "Don't be afraid to write your own test harness helpers." So this is a real code base. It's real Go code, so you can do things, anything actually. So figure out what's right for your project and write it into your test code. So I actually asked some people in the community for their testing tips. And I did it mainly on Go for Slack. And if you haven't joined, there's the invite. You can get an invite from that. So because it's a great way to interact with the community. Bill Kennedy said, shoot for 90% code coverage, 100% of the happy path. So what we're talking about here is we want most of the code, all of the happy path code, not the error handling bits and pieces, but all of the happy path code to be tested. And if we can get 90% of a package, that's a kind of great thing to shoot for. And then these commands will help you get there. This lets you see how much of your code was touched while you run your tests, which is nice. And you can even use this to visualize it. And you see your code, and it looks, it's brighter the more it's been tested, and duller the less. And by the way, with test-driven development, your code coverage is automatically pretty high. So you kind of, you get used to that high number. 90% does seem like a lot, but if you've TDD'd it, then it's pretty achievable. Ernesto Jimenez said, inject your dependencies. Yes, so what we're doing here is we have this an interface that's a kind of user service, and we're passing a mock to that. And that's kind of a nice practice to make sure that the code that you call is going to do the things you want to do. And we use this pattern where we have function field, and we set that, and then that in the mocked type also implements the interface. It just calls those fields. That means in your test code, you can actually stub out what you expect. We're actually mocking what you expect that component to be doing. And it's nice because it all lives in that same place. It's alongside your test code, which is cool. Coleman McFarland said, pass in testing T. So you're not returning errors all over the place. It keeps code clean. Testing framework, should I use one? I say whatever makes you happy. The core Go team think you don't need one, and they say, it's better to avoid dependencies and don't give new team members something to learn. So I get that, but it's up to you. And I've run out of time, but very quickly, this has been said already, but anyone that feels like they don't really fit into a tech community, or they've ever felt like they've been excluded or anything, well, come to the Go community, because this is exactly what we want. We want this diversity. We want all these people with all this different experience and stuff. I hope that was someone clapping. Yeah, thank you. And that's it. Buy my book. Huh? Yeah, it is on Amazon. Great question. Shameless, I know, I'm sorry. Thank you.